Today we are going to study about first chapter of 10th standard algebra, which is a linear equation in two variables. In the previous class we studied about linear equation in two variables. So let us have a brief recall of linear equations done in previous class. So an equation which contains two variables and the degree of each term containing variable is 1 is called a linear equation in two variables. So linear equation in two variables, say x and y, is generally represented as ax plus by plus c is equal to 0. Here the necessary condition is that a is not equal to 0 and b is not equal to 0, and a, b and c are real numbers. Suppose if we take a is equal to 0, then the first term becomes 0 and the equation becomes the linear equation in one variable. Similarly, if we take the second term, that means if we take b is equal to 0, then second term becomes 0 and the equation again becomes equation in one variable. So the necessary condition for the linear equation in two variables is that a is not equal to 0 and b is not equal to 0 and a, b, c are real numbers. Now we take two examples. The first is the 3x plus 4y plus 5 is equal to 0, and the second is the 2x minus 5y plus 6 equal to 0. In both these examples, the variables are xx and yy. Therefore, this type of equations are known as the equations in the same system. Now, if we think these two equations at the same time, then these equations are called as the simultaneous equation. Now, first we take the table of your textbook, page number 1, in which we have to identify that whether the given equation is the linear equation in two variable or not. जे आपल्याला सगळे इथे इक्वेशन दिलेले आहेत ते जे इक्वेशन आहेत ते लिनियर इक्वेशन इन टू व्हेरिएबल आहेत की नाही हे आपल्याला पाहायचं इथे. त्यासाठी जे व्हेरिएबल आहेत त्या व्हेरिएबलची डिग्री 1 पाहिजे आणि a इज नॉट इक्वल टू 0 अँड b इज नॉट इक्वल टू 0 अँड a, b अँड c आर रिअल नंबर. या सगळ्या कंडिशन ते इक्वेशन जर फुलफिल करत असेल तर ते इक्वेशन लिनियर इक्वेशन इन टू व्हेरिएबल असते. ठीक आहे. So we take the first example, which is 4m plus 3n is equal to 12. First we write this equation in the standard or general form, which is 4m plus 3n minus 12 equal to 0. Okay, here the two variables are m and n having degree 1, and a is the 4 and b is 3, which are the non-zero real numbers, and c is also the real number. Therefore, this equation is the linear equation in two variable. Now the second equation, which is 3x square minus 7y is equal to 30. The general form of this equation is 3x square minus 7y minus 13 is equal to 0. In this equation also, in this equation, the variable x has the degree 2. Therefore, this is not a linear equation in two variable. Now the third example, root 2x minus root 5y is equal to 16. The general form of this equation is root 2x minus root 5y minus 16 is equal to 0. Now in this equation, the variables are x and y having degree 1. Now the value of a is root 2, the value of b is minus root 5, and the value of c is minus 16. That means a, b and c are the non-zero real number. Therefore, this equation is also the linear equation in two variable. Now the third example, 0x plus 6y minus 3 is equal to 0. The standard form, this equation is already given in the standard form. So in this equation, the first term is 0x. That means the first term becomes 0. Therefore, this equation is the linear equation in one variable. Therefore, this equation is not a linear equation in two variable. Next example is 0.3x plus 0y minus 36 is equal to 0. Here also the second term 0y. That means the second term becomes 0. Therefore, this equation is the linear equation in one variable. Therefore, this equation is not a linear equation in two variable. Now the next. Now this equation is 4 upon x plus 5 upon y is equal to 4. We convert this equation using the rules of indices. Therefore, this becomes 4x raised to minus 1 plus 5y raised to minus 1 minus 4 is equal to 0. Now in this equation, the degree of the variable x and y is minus 1. Therefore, it is not a linear equation in two variable. The last example is 4xy minus 5y minus 8 is equal to 0. Here the first term, in first term the variables are x and y. The degree of the power of x is 1 and the power of y is 1. Therefore 1 plus 1, 2. Therefore the first term has the degree 2. Therefore this is also not a linear equation in two variable because the degree of this equation is 2. In this chapter we shall study about the various method of solving the simultaneous equations. In the previous standard, we already studied the elimination method and the substitution method. Your practice set 1.1 is based on these methods. Now let us revise the elimination method by taking the second sub question of the question number 2. The equations are x plus 7y is equal to 10 and the second equation is 3x minus 2y is equal to 7. Now here we use the elimination method for solving the simultaneous equations. In this elimination method, we have to eliminate either the variable x or the variable y by equating the coefficient. Here we eliminate the variable x. So we have to equate the coefficient of x. The coefficient of x is 3 in the second equation, and in the first equation the coefficient of x is 1. So we make the coefficient 3 of the variable x in the equation 1 by multiplying equation 1 by 3. So multiplying equation 1 by 3. So the equation becomes 3 into x, that is 3x. 3 into 7, that is 21y, and 3 into 10, that is 30. This is the equation number 3. Now take the equation number 1 and equation number the equation number 2 and the equation number 3. Now observe these two equations. Here the coefficient of the variable x is 3 and here also 3. The sign of the variables are same, which is the plus and plus. So to cancelize these variables, we have to take the subtraction. So here the constant term is 30 and here the constant term is the 7. The 30 is the larger than the 7, so we subtract the equation 2 from the equation 3. So we write the equation 3 first, which is 3x plus 21y is equal to 30. And then we write this equation 2 below it as 3x minus 2y is equal to 7. Now we take the subtraction here. So we have to change the sign of the second equation, sign of the each term of the second equation. Therefore, plus 3 becomes the minus, minus becomes the plus, and the plus becomes the minus. Here, now here, the plus 3x and minus 3x, that means the 3x is cancelled out. Okay. Now, here's the plus 21 and plus 2. Therefore, the addition is 21 plus 2 is the 23y. Now 30 minus 7 is 23. Therefore, this equation is now the equation in one variable. Now y is equal to 23 upon this 23 is multiplied to the y. Therefore, it divides the 23 at the right hand side. Therefore, 23 upon 23. Therefore, 23 ones are 23. Therefore, the value of the variable y is 1. Now, we put this value of the variable y in the either in the equation number 1 or the equation number 2. So we put this value of y in the equation number 2. Therefore, putting y equal to 1 in equation 2. Therefore, the equation 2 becomes 3x then minus 2y. Therefore, minus 2 into 1. The value of y is 1. Therefore, 2 into 1 is equal to 7. Now, therefore, 3x 2 into 1, that is minus 2, is equal to 7. Now, 3x is equal to 7 minus 2 becomes plus 2. Therefore, 3x is equal to 7 plus 2 is 9. Therefore, x equal to 9 upon 3. Therefore, x equal to 3 1s are 3, 3 3s are 9. X is equal to 3. Therefore, the solution of the given simultaneous equation is x comma y is equal to 3 comma 1 is the solution. Now we take the second example, which is in the different form than that of the first example. So the first equation is 1 upon 3x plus y is equal to 10 upon 3. The second equation is the 2x plus 1 upon 4y is equal to 11 upon 4. Now in the first equation, the coefficient of the x is 1 upon 3, which is the fraction. So we have to convert this fraction into the integral number. So we have to cancel this 3 by multiplying this whole equation by 3. So we have to multiply the equation 1 by 3. Now similarly in the second equation, the coefficient of the y is 1 upon 4, which is in the fraction form. So we have to convert it into the integral form. So we have to cancel the number 4 by multiplying the whole equation by 4. So multiplying equation 1 by 3 and equation 2 by 4. So multiply the equation 1 by 3. Therefore 3 upon 3, that means the 3 ones are 3. Therefore the remaining term is the 1x. So we just write x plus 3 into y. We multiply the second term by 3. Therefore 3 into y is 3y. Okay. Also we multiply the constant term by 3. Therefore 3 divided by 3, that is the 1. Therefore the remaining term is 10. It's the equation number 3. Now we multiply equation 2 by 4. Therefore the first term becomes 4 2s are 8. Therefore it is 8x. The second term becomes 4 upon 4, that is 1. And here the coefficient is also 1. In the numerator there is a 1. Therefore 4 upon 4 is 1. 1y, that means y is equal to. Now here also 4 upon 4. That means 4 ones are 4. 1 into 11 is 11. This is the equation number 4. New two equations are formed here. Now we use the method of elimination for solving these two simultaneous equations. So we eliminate the variable y. In the third equation, the coefficient of y is 3, and in the fourth equation, the coefficient of y is 1. So we have to equate the coefficient of y. So we multiply equation 4 by 3 so as to equalize the numerical value of the coefficient of variable y. So multiplying equation 4 by 3. Therefore it becomes 3 into 8, that means 24x, plus 3 into y, that is 3y, 3 into 11, that is 33. This is the equation number 5. Now we take the equation number 3 and equation number 5 for finding the solution of these equations. Now here the variable y has the numerical value 3 plus 3, and here also the variable have the numerical value plus 3. That means the sign of both the variables is same. If the sign of both the variable is same, then we take the subtraction. So here the constant number is the 33, and here the constant is 10. 33 is larger than 10. Therefore we subtract equation 3 from equation 5. So subtracting equation 3 from equation 5. So first we write the equation number 5, which is 24x plus 3y is equal to 33. Now we write the third equation, which is x plus 3y is equal to 10. Now we take the subtraction. So we change the sign of each term of the second equation. Therefore minus plus become minus, plus become minus. Now here 24 and the coefficient of x is the 1. Therefore 24 minus 1 is 23x. Here is the plus 3y and minus 3y, therefore it get cancelled. Now 33 minus 10 is the 23. Therefore we get the equation in one variable, which is 23x is equal to 23. Therefore x is equal to 23 upon 23. Therefore the value of x is equal to 1. Now by putting the value of the variable x, which is 1, in the equation, either in the equation number 3 or 4, we get the value of y. Therefore putting x equal to 1 in equation 3. So here the equation 3, the value of x is 1, therefore 1 plus 3y is equal to 10. Therefore 3y is equal to 10. This plus 1 becomes minus 1 at the right hand side. Therefore 3y is equal to 9. Therefore y is equal to 9 upon 3. Therefore y is equal to 3 3s are 9, that is 3. Therefore the value of y is 3. So the solution of the given simultaneous equation is x comma y is equal to, the value of x is 1, therefore 1 comma 3 is the solution.